It's very unstable. It's about to explode. The thing is, it could be tomorrow or it could be during this broadcast, and it would shine like a second sun in the sky. The James Webb Telescope has just detected a sudden 250% increase in Betelgeuse's brightness. Betelgeuse, the red star situated at the shoulder of the Orion constellation, has been exhibiting some weird behavior, fueling anticipation for a once-in-a-lifetime spectacle. Some say the increase in brightness could be the star getting ready to go supernova, but when exactly is it going to happen? Experts speculate that it could be soon. Join us as we take a look into the depths of space and delve into the mysteries surrounding this celestial giant. After all, Betelgeuse is capable of reshaping our entire understanding of the universe. A massive increase in brightness, even if you're not familiar with its name, you've likely gazed upon the magnificent Betelgeuse, a radiant reddish dot shining brightly at the shoulder of Orion, that well-known constellation. Right now, Betelgeuse is incredibly massive. In fact, if we were to put it at the heart of our own solar system, its outer surface would reach beyond Jupiter's orbit. To this day, this colossal and easily observable star continues to fascinate us. Unlike most stars, Betelgeuse changes before our eyes due to its relatively close proximity to our galaxy. Betelgeuse is classified as a semi-regular variable star, meaning its brightness fluctuates, sometimes dramatically, as it steadily moves toward an eventual grand collapse in a supernova explosion. Although already quite conspicuous, Betelgeuse has become even more interesting in recent years due to unexpected fluctuations in its brightness that we still struggle to comprehend fully. Why is Betelgeuse shining so brightly and behaving so strangely? It's uncharted territory, but its recent behavior was caused by an event back in 2020. Betelgeuse went through a period known as the Great Dimming in 2019 and 2020, which we'll get to later. Because of it, the nearest red giant star to Earth is now pulsating at double its usual speed, illuminating the early evening sky in the southern hemisphere. This strange behavior of one of the brightest stars in the sky is providing scientists with unprecedented insight into the demise of stars as it rapidly transitions between its bright and dim states. In recent times, Betelgeuse has occasionally exhibited more than a 50% increase in brightness. However, on May 20th, 2023, Betelbot reported something strange. Betelbot is a Twitter account dedicated to tracking Betelgeuse using information from the American Association of Variable Star Observation. It tweeted a staggering 142% surge in brightness, and now the most recent updates indicate a 150% increase in brightness. Astrophysicist Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics notes that it currently ranks as the 7th brightest star in the night sky, climbing 3 places from its usual 10th position. If you're in the southern hemisphere, you can easily see Betelgeuse shining brightly in the early evening. Just look for it located at the shoulder of the Orion constellation. You can also see Betelgeuse from the northern hemisphere when the days grow shorter. Dr. Sarah Webb, an astrophysicist from the Swinburne University of Technology in Australia, points out that one of the coolest things about Betelgeuse is that we can actually see the final stages of a big star's life happening right now, which is something we've never been able to study in so much detail before. By watching how Betelgeuse behaves, we can learn important things about what happens to red giants before they explode as supernovae. When it eventually explodes, it could become incredibly bright for about a week, even during the day, and it might even cast shadows at night. This has caught the attention of both amateur stargazers and professional astronomers. Everyone is excitedly waiting for a really special event. You see, one day Betelgeuse will explode and end its life in a supernova, and since we're just 650 light years away, we'll have the best view of this amazing cosmic explosion. Heidi Morris, a scientist at Los Alamos National Laboratory and the president of Pajero Astronomers and Astronomy Club, says that people really love Betelgeuse. It has been going through these changes in brightness for a very long time. Astronomers have known for a while that Betelgeuse brightens and then fades again. People from Aboriginal Australian and ancient Greek cultures even noticed this pattern thousands of years ago. Normally, the brightness cycle of Betelgeuse lasts around 400 days, but right now the star's brightness is changing much more quickly, about every 130 days, as observed by Andrea Dupree, who studies the star. This unusual behavior started in 2019 after Betelgeuse forcefully blew off a part of its outer atmosphere. So, these changes in brightness are not typical for Betelgeuse. But does this mean the star is going to explode into a supernova? It's hard to say, as this is completely new territory. According to a paper written by Dupree and other scientists from Harvard and the University of California, Berkeley, it will take another 5 to 10 years before Betelgeuse goes back to its usual cycle of changing brightness every 400 days. The authors say that Betelgeuse has never been the same after the Great Dimming. It's been acting differently in terms of its light and radial velocity. Still, Betelgeuse is a massive red supergiant star that has lived a fast and intense life. It's only around 10 million years old, while our Sun is 5 billion years old. Betelgeuse is currently in the final stages of its rapid evolution. Eventually, when it exhausts its fuel, the core will collapse under its enormous mass, resulting in an explosion that can outshine an entire galaxy. It's bound to happen, but like everyone else, we're curious to know when it will. When is it going to blow? There is a lot of speculation about when Betelgeuse will eventually explode in a supernova, but experts are doubtful. Roger, an associate professor of astronomy at the University of Portsmouth who studies supernovae and has even written a book known as Supernova, says that we currently have no way of predicting when stars will explode, so we have no clue about when exactly Betelgeuse will go supernova. It makes sense that it's really uncertain because, throughout human history, we haven't had many supernovae to study. Despite the hopes of astronomers, chances are slim that anyone alive today will witness the spectacular explosion of Betelgeuse. Betelgeuse still has a lot of work to do before it can go supernova. As a red giant star, it undergoes a series of fusion processes involving different elements like helium, carbon, oxygen, silicon, and iron. When a star becomes a red giant, the intense pressure in its core allows it to fuse helium into carbon. This process takes thousands of years. Eventually, the star progresses to fuse carbon and helium to form oxygen, and the cycle continues, producing heavier elements like iron. Then, at the end, the star won't be able to get energy anymore from fusion reactions, leading to it collapsing under its own weight because of gravity. The end result will either be a black hole or a neutron star, based on the analysis of chemicals in Betelgeuse's atmosphere. It appears that the star is currently in the earlier stage of this fusion process, specifically fusing helium into carbon in its core. Unfortunately, we can't see what's happening inside the mighty Betelgeuse. Jared Goldberg, an astrophysicist at the Flatiron Institute, points out that Betelgeuse will explode at some point, but that soon could mean within the next 10,000 to 100,000 years. Goldberg mentions that he wouldn't risk his career on the immediate explosion of Betelgeuse. There's some interesting evidence suggesting that Betelgeuse won't be exploding for a very long time. If you dig into historical records, you'll find that over the past 2,000 years, the star has actually been getting redder. Jason Ibra, who studies stars and the history of astronomy at West Virginia University, explains this fascinating observation. So, it seems like we might have to wait quite a while before Betelgeuse blows up. This implies that Betelgeuse transformed into a red supergiant relatively recently in cosmic terms, so it could take a considerable amount of time for the star to deplete its fuel completely. To the best of our knowledge, Betelgeuse is unlikely to go supernova anytime soon, according to Ibra. But what does NASA say about when Betelgeuse will go supernova? According to NASA, Betelgeuse is not expected to explode for another 100,000 years. Heidi Morris suggests that we shouldn't assume it will remain unchanged even in 10,000 years. We should stay attentive and let it inspire us to advance scientifically. Although it is highly unlikely that we will witness Betelgeuse's explosion in our lifetime, Dr. Sarah Webb reminds us that we cannot be certain. We should keep both our fingers and toes crossed and hope for some luck. It's important to note that we are observing Betelgeuse in the past. The light we see from the star is more than 600 years old. Theoretically, Betelgeuse may have already exploded, and we would be unaware of it. Indeed, this possibility exists, but it is far from definite. Past experiences have shown us that our expectations can be challenged. Prior to 1987, astronomers believed that only red supergiants could undergo a supernova. However, in the same year, a giant blue star in another galaxy exploded, surprising the scientific community. There is still much to learn, and we might be in for some surprises. By observing Betelgeuse, we can gain new insights into the life cycle of stars and the cosmic events that shape our universe. Certainly, Here's an additional 800 words, continuing the discussion on Betelgeuse without repeating the previous content. The recent dramatic fluctuations in Betelgeuse's brightness have sparked a surge of interest in the scientific community and among amateur astronomers. These variations are not just about observing a star. They offer a unique opportunity to study the life cycle of one of the universe's most fascinating and massive stars in real time. Betelgeuse, a red supergiant in the Orion constellation, serves as a natural laboratory for understanding stellar evolution, particularly the end stages of a star's life. Betelgeuse's prominence in the sky and its proximity make it an ideal candidate for such studies. At about 650 light-years away, it's relatively close in cosmic terms, which allows astronomers to observe its changes with greater detail than most other stars. This proximity provides a rare chance to study the processes that occur in the final stages of a star's life, particularly as it nears the end of its nuclear fusion phase and approaches the supernova stage. One of the key areas of research involves understanding the physical mechanisms behind Betelgeuse's brightness changes. The star's recent brightening is linked to the star's outer layers undergoing complex interactions. The exact cause of these changes remains uncertain, but theories suggest that they may involve convective cells, giant plumes of gas that rise and fall within the star's outer layers, or the presence of varying amounts of dust and gas. These factors could cause the star's light output to fluctuate dramatically. The Great Dimming event that occurred in late 2019 and early 2020 was a significant anomaly in the study of Betelgeuse. During this period, the star's brightness dropped by about 60%, which is an unusually large decrease. Initial hypotheses suggested that this dimming could be due to a cloud of dust blocking the star's light. However, this theory has evolved as more data has been collected. High-resolution imaging and spectral analysis have provided insights into the star's surface activity and the presence of large convective cells that could influence the observed brightness changes. Betelgeuse's behavior has also led to discussions about its eventual explosion. While it is well established that Betelgeuse will eventually go supernova, the exact timing of this event remains uncertain. The star is currently in a late phase of its evolution, and its core is undergoing the final stages of nuclear fusion. As it exhausts its fuel, it will transition to a supernova, which is expected to be one of the most spectacular cosmic events observable from Earth. Scientists are closely monitoring the star for any signs that might indicate the imminent approach of this dramatic end stage. Another aspect of Betelgeuse's study involves its interaction with its surroundings. The star's massive size and luminosity mean that it has a significant impact on its local stellar neighborhood. The strong stellar wind generated by Betelgeuse can influence the surrounding interstellar medium, affecting the distribution of gas and dust in the region. This interaction can also play a role in the formation of new stars and planetary systems in the vicinity. Betelgeuse's variability and the recent increase in brightness have also led to a reevaluation of its stellar classification. Historically classified as a red supergiant, the star's recent behavior has prompted scientists to consider whether it might be undergoing changes in its internal structure or composition. These changes could affect its classification and provide new insights into the diversity of red supergiants and their evolutionary paths. The study of Betelgeuse is not just about understanding one star. It provides a window into the broader processes that govern the life cycles of massive stars. By examining Betelgeuse's behavior, scientists can gain insights into the physics of stellar evolution, supernova mechanisms, and the role of massive stars in the cosmos. This knowledge contributes to our understanding of the universe's structure and the processes that shape it. Moreover, Betelgeuse's variability has captured the imagination of the public and the media, drawing attention to the field of astronomy and the study of stars. The prospect of witnessing a supernova in our lifetimes, even though it remains uncertain, has fueled interest and excitement about space exploration and astronomical research. This heightened interest is beneficial for the scientific community, as it encourages funding, education, and outreach efforts. As Betelgeuse continues to evolve, scientists will rely on a combination of observational data, theoretical models, and simulations to better understand its behavior. Advanced telescopes, both ground-based and space-based, will play a crucial role in monitoring the star's activity and capturing high-resolution images and spectra. These observations will help refine our understanding of the star's evolution and its eventual transition to a supernova. In addition to direct observations, researchers use computer models to simulate the internal processes of Betelgeuse. These models take into account various factors, such as the star's mass, composition, and age, to predict its future behavior. By comparing these predictions with actual observations, scientists can test and refine their theories about stellar evolution and supernova mechanisms. Betelgeuse's current behavior also highlights the importance of continued research and observation. The star's dynamic nature serves as a reminder of the complexity and unpredictability of stellar processes. Each new discovery and observation contributes to a deeper understanding of the universe and our place within it. As we await the next developments in Betelgeuse's story, the ongoing study of this remarkable star will undoubtedly yield new insights and discoveries that enrich our knowledge of the cosmos. In conclusion, Betelgeuse is a source of fascination and intrigue for both scientists and the public. Its dramatic fluctuations in brightness and the possibility of a future supernova make it a compelling subject of study. As we continue to observe and analyze Betelgeuse, we gain valuable insights into the life cycles of massive stars and the processes that shape the universe. Whether or not we witness its supernova, the study of Betelgeuse will continue to inspire and inform our understanding of the cosmos.